More than 4,500 years ago, ancient builders created monuments that still challenge modern understanding. The largest pyramid alone contains over 2 million stone blocks, each weighing several tons. The precision of the stonework suggests careful planning, rather than brute force alone. No cranes, engines, or metal machinery were available to the ancient builders. The pyramids were built near the Nile, Egypt's primary transportation and supply route. Most limestone blocks were quarried locally, reducing long-distance transport challenges. Harder granite, sourced hundreds of kilometers away, was reserved for critical structural spaces. Moving massive stones across desert terrain required careful logistical solutions. The Nile likely served as a seasonal highway for transporting heavy materials by boat. Annual flooding allowed boats to reach closer to construction sites than today. Archaeological evidence indicates a large, organized labor force rather than enslaved workers. Housing, bakeries, and medical facilities suggest long-term planning and care. Sustaining thousands of workers required a reliable food distribution system. Tools were simple, relying on copper, stone, and wood rather than advanced metals. Repeated tool marks show patient shaping through sustained manual effort. The structure aligns with true north to remarkable accuracy. Engineers likely used star positions to establish orientation. The foundation was leveled with extreme precision, possibly using water-based methods. Construction progressed in horizontal layers, rather reorganization vertical walls. Most scholars agree ramps played a key role, though their exact design is debated. Raising heavy blocks to increasing heights introduced growing structural risk. Weight was distributed outward and downward to maintain stability. Such precision required coordinated teams following strict measurement standards. Some construction details remain debated due to limited surviving evidence. What is clear is that these structures were the result of engineering, not myth. As the pyramid grew taller, each additional layer increased the difficulty of construction. Ramps likely evolved as construction progressed, adapting to changing height and load requirements. Some researchers propose internal ramps concealed within the structure itself. Space limitations required careful planning for maneuvering stones at height. Gravity posed a constant risk, as blocks were positioned near exposed edges. Accuracy did not diminish as construction reached higher elevations. Ancient engineers managed load paths to prevent internal collapse. Relieving chambers diverted weight away from interior spaces. Transporting and placing granite demanded exceptional coordination. Standardized measurements ensured consistency across millions of stones. Poorly shaped stones were likely rejected before placement. Labor was likely organized in rotating teams to maintain productivity. Construction likely spanned decades rather than generations. The final stages demanded the highest precision and coordination. The placement of the capstone remains one of the least understood steps. Originally, polished casing stones gave the pyramid a smooth exterior. Later stone removal altered the pyramid's appearance, but not its structure. The core engineering choices ensured long-term stability. Strength and simplicity were prioritized over speed or efficiency. Every construction decision contributed to the monument's survival. By the end, the structure stood as a complete engineering system. Every construction decision contributed to the monument's survival. By the end, the structure stood as a complete engineering system. Its completion marked a turning point in human construction capability. The conflict was no longer how it was built, but what it represented. The final chapter lies in the pyramid's lasting impact. After completion, the pyramid remained structurally stable through centuries of natural forces. Surveys show minimal settling, indicating accurate load calculations. The structure withstood regional earthquakes that damaged later buildings. Many later constructions failed where the pyramid endured. Simple geometric design reduced long-term structural stress. The pyramid required no maintenance to remain standing. Precision was achieved through measurement, repetition, and skilled labor. Knowledge was likely passed through structured training rather than written manuals. Some construction methods remain uncertain due to limited surviving evidence. No credible evidence supports non-human or advanced lost technologies. Modern engineers recognize the structure as mechanically efficient. The design maximized compressive strength while minimizing tension. Religious belief provided motivation for sustained effort. Time tested the structure more thoroughly than any experiment. Few buildings in history have matched this longevity. Some techniques remain debated, not mysterious. The achievement relied on organization, physics, and patience. It challenges assumptions about ancient human capability. The pyramids remain a benchmark of engineering achievement. Not because the methods are unknown, but because they demand respect.